We got a lot of people here in person. We got people tuning in. Our issue is that I thought we had a hot plate, and we have a scale that looks like a really old school hot plate, which sucks because we have to heat water for this experiment, which we could do in the microwave, but it's not as fun, and also it's gonna be boring for us to all go sit by the microwave. So we're gonna try to set up this crazy engineering situation to get our heated water. But basically what we're gonna be doing is we're gonna be taking our chicken liver, we're gonna be putting it in test tubes, and we're gonna be heating it to different temperatures to talk about enzymes. So I'm gonna go ahead and share my screen here for those of us tuning in from home, and those of us who are here. If you have your lab printed, you're gonna wanna be looking at it. If you don't, you're gonna listen. Okay, so we're gonna be doing, how does temperature affect enzyme reaction rate, right? You were supposed to read this background, which should have been a review, and answer the pre-lab questions. If you didn't do that yet, then that's cool. Okay, if you have to leave, that's fine. You're gonna do them after, it's not a big deal, but understanding enzymes is a big deal, right? So the only reason that you're existing right now is because of enzymes. Enzymes are breaking down things in your body, building things in your body at a fast enough rate so that you can actually exist, right? Things will generally break apart on their own. Like if you think about food, right? It eventually decomposes, right? That takes forever. You can't wait after you eat 2 weeks for the nutrients to break down so that you can have them in your body, right? You would die. Enzymes break them down really quickly, right? The enzyme we're gonna look at for this lab actually also is important because it helps you break down poisonous materials in your body. So we have, do you need the letter?
No.
You're thinking, okay. All else fails, we'll use the microwave. Okay, so we have something that everyone probably knows what it is.
Hate that stuff.
Hydrogen peroxide, right? You probably poured this on your cuts, or let me rephrase that. Your parents probably held you down and poured it on your cuts while you cried and screamed, right? So we all know what it is. It's a bubbly thing, right? It's used to help disinfect because it kills stuff. It's a poison, right? If you were to drink this, it would not end well for you. Actually, you would be okay. Your body would deal with it, but would not recommend. So your cells are constantly making this as a byproduct from reactions that they're doing, and you need to get rid of it. So you have an enzyme in your cells called catalase that breaks down hydrogen peroxide into water and oxygen. So we have some chicken livers here.
Yum.
$2 worth of chicken livers, very cheap food. People eat them, right?
Like they cook them?
Mm-hmm.
Or
Yeah,
they just eat
people
them raw?
like saute it with like mushrooms and onions. It's also not the worst.
Yeah, it's in between.
It's like probably not what you would pick from a menu, but people might want it. Yep, some people use this as mouthwash. Very true.
Oh,
And after you have like oral surgeries, like if you have your wisdom teeth taken out, then you got to swish with this stuff. All right. So guess what? It's local chicken livers. Important. Okay. I like that. Only the adult in the room laughed at that. Come on, guys. It's funny because people here are really obsessed with local stuff. Okay. So we have our chicken livers, right? These contain tons of enzymes. They contain catalase. They also contain millions of other enzymes, right? Your liver does a lot of detoxing of your body, breaking things down and helping you get through things. So chicken livers are going to have tons of enzymes. They've been refrigerated since the chicken was killed, right, approximately. So they still have the enzymes in there. They're still intact. So what we're going to do is we're going to pour the hydrogen peroxide on the chicken liver, and we're going to see bubbling, right? When you're like, oh, that sounds cool, right? We're going to do it at different temperatures because enzymes are very, very special. They need a specific temperature. they need to be, can you guess what temperature they probably need to be at?
Room temperature.
Room temperature. Those are the only guess. We're all agreeing. Is your body room temperature? No, right? So.
But was I right?
We'll see.
Okay.
I'm not going to give it away. But other things can affect them too, like salt levels. Someone said hot. Okay. Salt levels, right? If you have too much salt, too little salt, that can impact the enzyme. pH, right? Your body has a pH of 7.4. It's a little bit basic, right? That's right. We're all a little bit basic on the inside. And your pH is kept constant all the time. If your pH fluctuates even a little bit, you would die, right? So enzymes need that pH of 7.4. Otherwise, what happens to them, it's called denaturing. They actually like change shape and become disfigured. So imagine a Pac-Man. Imagine you light Pac-Man on fire.
No.
And then blow him out. Like you just light him on fire and then blow him out. He's going to be like demented, right? That's what happens to enzymes when they're in the wrong conditions. They change shape. They can't work. They're all about the shape. Even think about if you have a key that opens your house and somebody cuts part of the key off. You're not getting in your house, right? That's the same concept of the enzyme. If the enzyme changes shape, it's not working. So we're going to prove that with the temperature thing today. We're not going to do pH and salt and all that, but just know that it's true. All right. So what we're going to do is we need a brave volunteer who wants to touch the chicken livers.
Oh, I love touching things.
And wants to cut them into little pieces for us.
Oh, I got this.
Make sure, by the way, that if you haven't predicted already, that you at least do that. So predict in your mind, predict on your paper. Which temperature is going to be the best here?
Oh, dude.
Right? We have ice cold water, room temperature water, body temperature water, right? Which we'll try to warm it up to around 90 degrees. And then boiling water. So those are your options. So pick which one of those you think the enzyme is going to function the best at and just write why. Right? It doesn't have to be super detailed. You need something to cut this on, right?
Oh, looks like guts or something.
They're fun.
This won't work. Yes. You know what? Just kidding, guys. Just kidding. I don't like.
Okay. So
Gross.
Is it fun? Have you seen the little chicken hearts that they have?
That stinks really bad.
It's liver.
What are we gonna cut it on?
All right, we're just gonna cut it on the table.
Oh, fun.
Oh.
So let's move the computer
Scoot that back.
out of the way. We have a plastic knife. Okay.
Wait, would you guys like to
So,
see us cut
oh
it?
yeah, we gotta have it. We'll angle it down a little bit. We're gonna move over there in a second too. So chicken livers.
Yeah, ew, it's gonna trip.
As I pour blood on the computer. Actually, you can cut it on this thing maybe.
Oh, okay.
So we have 4 temperatures and we have a control. We're gonna need 5 pieces of chicken liver that will fit in here, and we want them all to be approximately the same size.
Okay.
Okay?
Okay.
So who's gonna help hold these and help make sure they're the same size? We need like quality control over here. Do you want scissors instead of a knife?
Yeah. It's gonna be too sloppy.
Accurate.
You're gonna be sawing at the liver.
Okay, I'm
But yeah,
gonna pretend
so-
that's not liver.
Oh.
Oh, yum. Who doesn't like liver?
But look at how big this is. Think about how big chickens are. They're not that big. This is huge. Livers are big. They take up like the entire inside of you almost.
Thanks.
See, I'm surprised no one's making any comments.
Yeah.
The last thing someone said was hot. That was it. And not about the livers. Okay.
Okay, here we go.
Start chopping away.
You
Yeah,
volunteered.
it's cold.
Don't be like this.
It's cold. Ew, it's cold. Guys, I don't think I can.
It's like blood starts like gushing.
It looks like a ton, guys. Ew.
Oh, gross. It's gonna be big enough to
What's
fit.
your happy place?
Happy place.
I'm just cooking meat for my family.
Yeah.
You just cooking.
Oh,
So if I put
Okay, because it's too entertaining This is. That is gross. Okay, you need to.
You want to switch?
Here. Put that in there.
Okay.
How's the liver cutting going?
No, it's going
It's
good.
good. It's doing great. Oh,
As good as it can go, I'm guessing.
Yeah.
Oh, you know what, too? We'll get somebody to be in charge of the Snapchat. But I gotta go get my backpack. All right, here.
these two are
It
done.
slides down the tube really fast, guys. Like really
It's
fast.
lit.
Well, it's slippery.
It's slippery. Dude, I can't put. Oh, it's stuck to my
What did I
finger.
do with my backpack? It seems strange.
I don't
Okay.
know.
Oh, actually, I know where it is. It's in the workroom.
Come on, liver.
Someone said because this is too entertaining to speak.
Well, that's true. Actually, let me get my coffee out of here in case
Yeah, just in case.
somebody gets over there.
Before I flick a liver at your
Yeah.
coffee. Oh, this is gross,
And then
guys.
another job that people can have that's less gross is being in charge of temperature. Right? Yeah. That's
Okay.
Is this too big?
fun, getting to use the thermometers.
I think it's good.
Okay, be
But
very
they all have
careful
to be
because they
the
are
same
glass.
Oh, true.
size.
Dude, this is cold. It's like making my hands freeze, guys.
Okay. One more.
I know. Imagine if you got your temperature taken. with
You
the
know, I
same.
never imagined myself doing the announcements and then now touching chicken liver for a virtual lesson. Touch that.
This isn't bad.
Okay, so. You guys
Ever like pluck the feathers off the chicken?
have I?
Yeah.
No.
Oh, never mind.
Wait.
Wait. Then
Oh, we're done. We done. Virtual reality
So
liver.
let's also get some
Yeah.
room
True that.
temperature going.
Ew.
you should wash your hands.
Dude, this is. Should I put it back?
Yeah, you can put it back.
Okay.
In fact, you can take it home.
Thank you. It's a
Or-
gift.
I think I'm gonna save it. I think I'm gonna gross out the middle schoolers on Friday.
Okay.
I'm just gonna come in and be like, guys, you wanna see something? And just open it. Not even explain.
Dude, I'm gonna,
These are little kids' livers.
dude, you should be like, if you guys don't behave, it's gonna be you.
This is what happens.
Yeah, if you don't behave, then the liver is coming towards you.
Yeah.
No.
Dude, I want to freak my mom out so bad. She's an animal lover, and she doesn't. I'm gonna be like, I touched a chicken's liver. Okay. Do you want me to leave them on people's doorsteps for the next time? Oh, dude, that's a good idea, though.
Chicken livers should have more purpose, I think, in Halloween decorating.
Where do you buy this?
Just the grocery store.
Like Fred Meyer's has that.
Yeah, you just sometimes you have to ask.
$2.
Because sometimes it's in the back. Like
I
they don't have them on display, but they always have them in the grocery store.
I'm
Okay, so we have two waters here. We have ice cold water and we have room temperature water. Can I put this in? Yes, so. Okay. So we're getting our waters set up here. We have our ice cold water, which we're in Celsius, so it should go down to 0, right? It should be close to 0 degrees Celsius. We also have room temperature water, which the temperature of the room is, it looks like it's somewhere around 18 degrees Celsius, which is approximately normal. You guys are gonna be in charge of the hot and body temp waters with the
Not like me.
thermometers.
just like,
So we're gonna take 2 of our chicken livers, right? Looking nice in the tubes here. And we're gonna place one of them here in the ice water and one of them in the room temp water. And you may be wondering why we're not just directly putting the liver, right? We don't want the liver to get wet. We just want it to get to this temperature. So we're probably gonna leave it here we'll wait probably about 8 to 10 minutes so that the liver can get to the right temperature. And we have Mr. Scott over there lighting some stuff on fire. We're using restaurant food warmers.
This is safe.
Because that's what we have in the school, not a hot plate. So we're gonna roll with it. I just walked around for inspiration. I almost thought we could use the coffee pot and heat water in that, but this is better because it's real fire. And then we're going to be pouring our hydrogen peroxide. So I'll actually get a graduated cylinder for that. We'll need a couple of volunteers who want to add the hydrogen peroxide. What we're going to do on your data section is we're going to be recording the amount of oxygen. So we're actually going to measure the height of the bubbles, right? Which is not the most efficient way to measure, but it's going to show us, right? Some of them will have a ton of bubbles. Some of them will have like 3 bubbles. So it'll give us an idea. And then after we do that, we're going to actually, I'm going to prove to you that oxygen is being released. And I'll explain how I'm going to prove that later. But it involves fire, so it's fun. All right. Brand new hydrogen peroxide. By the way, this stuff actually goes bad, right? If you leave hydrogen peroxide, like let's say it's like 5 years old in your house, it will break down into water and oxygen by itself, even without the enzyme, right? So that's why it has an expiration date, or it's supposed to.
It's usually really
Oh, there we go.
tiny.
So this one expires in 2019, right? Oh, they can't even see me. 2019. So hydrogen peroxide does do this reaction on its own, right? It does break down slowly over time. Again, that's in 3 years, right? So you can't wait 3 years to get rid of poison from your body. Just move this guy out of the way a tiny bit.
Hillary wants to see the chicken liver.
I don't want to see it. I don't want to see
Ew.
Record the reaction. Listen, so we're currently chilling 2 of them, room temp and ice cold, and then we're gonna have 2 of them.
Why? What are you doing?
We're testing it. Wait, no, you guys tell her. What are we doing?
So we are testing the chicken liver in room temperature and in cold water.
And what are we testing it for?
Yeah, guys.
Cancer. Cure for cancer.
That is gross.
Release. So we're measuring the amount of oxygen that's released when you pour hydrogen peroxide on the liver. The liver has enzymes in it, and it'll break down the hydrogen peroxide.
Oh my gosh.
This chicken liver in your hair.
Smells like fire over there.
Does it smell? It does.
Yeah, it does smell really bad.
It doesn't smell that bad, but it
not
smells.
bad.
Do you want to smell?
Do you have one? I thought you were having multiple chicken livers.
There's like
There's like
10 in there.
So that's not.
But that's a real email that
You know
Rachel
what this
sent
looks
me.
like?
How many chicken livers do you want?
This looks like a cow's tongue.
Very tongue-like.
Even though I don't know.
All right, so people at home, we're really just waiting right now for our livers to get to the right temperatures, right? Which isn't really the most exciting thing. We're also grossing people out that happen to be here that don't even know about the chicken liver. So what we're gonna do for a control is we're just gonna pour regular water onto our chicken liver to make sure that these reactions are because of the hydrogen peroxide, right? I know that sounds kind of silly. We'll talk about later what we could also have used as a control. There's many options here. So we will get a graduate. All right. I need somebody to fill this up with 5 milliliters of water. Okay. And then while we're waiting, we can have one of you guys fill these up with 5 milliliters of the hydrogen peroxide. Yes. It doesn't have a cover on it. Okay, we need rulers. Sounds like a party, right? Yep. Darn it. All right, so we're going to be measuring with the ruler. Now, the thing is, the reaction may actually go higher than the tube. So if that happens, we'll just measure as much as we can, and we'll do an approximation. when we start actually adding the hydrogen peroxide, I want you guys to pay attention to other things, right? What does it look like? How long does the reaction go? You're even going to touch it. Does it feel hot? Right? One of the signs of a chemical reaction is things getting hot or cold. Okay, I guess we'll wait for them to come back before we do the control. Let's see. Did he turn the flames on over there?
I think you did.
Yes, we're very hot. All right, my thermometer peeps.
What up?
Perfect spots. Okay. So I need one of you to put the thermometer in here. Try to hold it in there and not let it touch the bottom. When it gets close to 37, which it already is at. Because that's around body temperature. This one, we're gonna let it boil. So you can actually just take the thermometer out, and then once it starts boiling, we'll measure the temperature. Okay. So this one is good to go. It's we only need to heat it a little bit. Yeah, this is working amazing.
Oh,
Thank
good.
you so much. Seriously. Yeah, it's an ethanol.
Is your
flame.
start?
It's very interesting. Yeah, just set it there. Okay, so we got to start. What happened to them? Where are they? We got to start doing this.
I told her to come.
Okay. All right, guys. So our ethanol flame has worked really well. We'll go over there to the hot ones in a second. So we'll start with our control. Okay. This is going to be so exciting. We're pouring water onto the liver as our control. We're doing the control. So what's going to happen when we pour water onto the liver?
It's gonna bubble.
Okay, nothing happened. It looks like one of those weird jars that people have in their house. Great gift idea. Chicken livers in a jar with water for all the people in your family that like weird stuff. There you go. All right. You're like, happy holidays. Have some chicken livers. Okay, so that was our control. Obviously, nothing happened, right? That's what nothing happening looks like. We poured water on liver. Now we're going to try our room temperature water, which you may want to note. Room temperature for us is about 18 degrees Celsius. It's actually a little colder than the room. I can feel now. Feel the liver.
Oh,
It's a little cold, right? But not too cold.
my hands.
No, it's okay. It was in the glass.
It's like
Okay. So I need someone who's going to come stand really close to me because they're going to measure the bubbles here.
I'm not really good at measuring, so don't look at me.
No one wants to measure the bubbles? All right.
No one does it, I'll do it.
We need you. Just hold it. I'll help you measure it. Okay. So I'm going to try not to let my hands get in the way of this
I didn't say no one
and
does
show
it.
people. But we have our 5 milliliters of hydrogen peroxide. We have our chicken liver at room temperature. We're going to add it and we're going to be measuring our bubbles.
Okay, which way does this go?
Hopefully you guys can see it. It's bubbling like crazy. It's getting very, it's going to go over the top. It's going to spill.
Yeah, it is.
Okay, but notice how vigorously it's bubbling. Does it feel warmer?
Yeah,
You can feel the heat a little bit from the reaction.
it's bubbling over.
I know, it's okay.
It's
Okay,
like soaking up the.
Don't get it on the computer.
the
germs
liver
on it.
is floating
It's-
in the hydrogen peroxide. It's like bubbling up. All right, I'm gonna keep my finger there, see how much higher it is. So hold the ruler next to it. What's the height there on this one?
Like 11.
11. All right, we're gonna write 11 centimeters for our room temperature liver. Right, it's still going, it's still bubbling like crazy. You can see the bubbles in there. We'll leave that, we'll just let that chill in its speaker for a little bit. I'm going to get my phone so that we can be Snapchatting this because it's very important to me. So make sure you write down 11 centimeters. We're going to do my other phone, my work, because I have two phones.
Oh, okay.
We're going to do the ice cold one next. Check the body temp one. See if it needs to go back on for a couple of seconds.
Where's Miss Dinsmore go?
She wanted us for her other phone.
So guys, while Miss
Okay, I'm back. Sorry. Apparently my phone wasn't in there. Which means it was in here the whole time. Or I lost it.
your phone's right there.
My other phone.
I told you.
Oh,
Okay. Now we need a Snapchatter.
I'll do Snapchat because I'm really good.
Okay, I'll do it. All right. So next up, we're going to do our ice cold liver, which our temperature here, it's not as ice cold as we would like. It's about 6 degrees Celsius. Right, 0 would be freezing. So it's not quite freezing, but it's pretty cold. All right, the liver definitely has gotten cold here. We're going to need a refill on hydrogen peroxide there. So we got our 5 milliliters of hydrogen peroxide. We have our freezing cold liver. And we're going to be pouring it in and getting ready to measure.
Oh.
Okay, we got some bubbling. More or less than last time.
Less.
Much less. Right? A nice controlled bubble. We're not scared that it's coming out of the tube.
That's like.
Hold on, give it a couple more seconds. Looks like it's rising up a little bit more.
The liver isn't floating anymore.
Notice that the liver is like stuck on the side kind of for this one.
Oh, there it goes.
Oh, now it's floating. It's really getting in the, oh, wow, this one. So this one is still producing quite a bit of bubbles. It's going slower. All right, go ahead and measure. Go ahead and measure. Go ahead and measure it now. Go ahead and measure it now. This one.
It's like
9?
Yeah.
Right, we're going to go with 9. 9. These are centimeters, by the way. Ice cold, 9 centimeters. 11 centimeters. All right, and then we are going to go to our control was 0, right? Well, actually, our control, technically, we should measure to the top, right? Because that's kind of what we've been doing. But no, we'll just say it's 0. It didn't do anything. Okay, so we're going to go to body temperature next, which means we're actually going to be relocating. So we're going to move here. If you actually want to take this and add 5 more milliliters, you can bring those over there. Okay, very careful. We're near the purple flames. Notice what's happening to the liver in the boiling water. It's cooking. Okay, so yeah, let me take this just so that I'm not like standing too much here. All right, so now we have our body temp liver, which our temperature for this one is, what was the last temperature you got?
736 or 37.
37. Oh yeah, it's pretty close. It's right around, it's still going up. Good, so 37 degrees Celsius is body temperature, right? 98.6 for those of us who are more Fahrenheit. So we have a nice body temperature liver here. Pay attention to how much faster, where's the one that has stuff in it? Pay attention to how much faster or slower this reaction happens, right? And then obviously we're gonna measure the bubbles. There's not enough space in this classroom, clearly, for all of the things that I want to do. Okay. Here we go. Okay. We got some bubbling going on. Not looking as vigorous as I was hoping.
Do you want me to measure?
Yep.
Handy dandy
Ruler.
ruler right here.
Hmm.
So this is like your fingers.
What was?
10.
Yeah, like.
Wait, it's still going a little bit. Actually, it looks like it's starting to kick into high gear now. Possibly.
So what would you say that would be?
Let it keep going. I think it's into, well, maybe not. It's kind of
11.
11. 11.
For the what?
For the body temperature, we got 11. All right. So far, so good. Boiling. Oh yes, the liver looks nice and boiled. That looks beautiful. All right, let's see. How am I gonna touch it? Because I don't want to burn myself.
Where's the clippers? The clippers?
The climpers?
No, whatever they're
No,
called.
you know what? I think we have a. Oh yeah. Oh wait, no, I don't know. Is that gonna break it?
Oh no, in the.
We have a blanket in here.
You're gonna use a blanket that's gonna like. And then the smell is.
I think it's like a fire blanket or something. I don't really know what this is.
Like a mat.
It's a blanket. Okay.
Oh, I don't.
Oh, look at this guy. It's coming out of the tube now.
Hold on, let's get you doing this.
Actually, this might not work.
Yeah, I don't think it's.
You guys, if people ever tell you that you can't do science with no supplies, tell them they are wrong. Okay. So there's our liver. Notice the color. It's brown. How's it smell?
Whoa, that smells like ham or something.
Oh, gross.
It smells cooked. Okay. We need 5 more milliliters of the hydrogen peroxide. We gotta do this quickly. Yeah, I can smell it now. It's like, oops, sorry. Can't see the edge here. Oopsies. Making a big mess. All right.
Okay.
Ready?
Oh.
What happened? What happened? Nothing. It's barely bubbling. All right, I can touch it now. All right, barely any bubbles. A little more than the water, right? We'll call that 0.5 centimeters because it is a tiny bit there. But barely any, right? And a lot of you may be thinking, wait, but I thought the hotter that we made it, the better it would be, right? But there's a certain point here where it gets so hot that you actually cook the enzymes. They're completely denatured at this point, right? This is enzymes denatured in the most extreme form. They can't function at all, right? There's like 3 of them still going. That's it. In the room temperature and the body temperature, right? Look, this reaction is still going, right? There's still bubbling happening in the body temperature liver because it's still working, right? Those enzymes can keep getting reused, right? They're not like disposable cups that you just throw away. They keep getting used over and over and over. So they're still working right now to break down every last bit of that hydrogen peroxide, right? Whereas the cooked liver and the really cold liver, not as much. If we could have gotten it a little colder, you'll see, once it gets too cold, it's not gonna work at all, right? So if we could have, like if we froze the liver, it wouldn't work.
Yeah.
So there's like a bell curve almost, a bell curve of how the enzymes are gonna work best. In a certain range, they're working really well. On the extremes, they don't work.
Yeah.
Right? So now we're going to prove, there's a couple questions here for you guys, and then we're going to prove oxygen. So which reaction lasted the longest? Well, the body temperature one is still going. What about our room temperature over here?
That was 11 centimeters.
Mm-hmm. Okay, the cold one is also still going. Room temp seems to finally have relaxed. So we'll check on that again to see which one is still going in a few minutes.
Yeah.
But obviously, right, it's going to be room temperature or body temperature here. And then other observations, right? Some people felt, you can feel the heat coming out of this reaction. It produces heat.
And
There's bubbles.
And then some you could smell, like that one.
The burnt or the cooked liver you could smell. You can also hear the bubbles.
Yep.
Right? It sounds like Rice Krispie treats or something. It's like, so you can hear things, you can feel the heat, right? All right, so how are we going to test for oxygen? So this is where it's going to get dangerous. Oh no, did he take the lighter back?
It's right here.
Oh, good. Okay. So usually I use Starbucks stirring sticks, which I forgot to get. So we're going to use toothpicks. So what we're going to do is we're going to take some liver and we're going to put it in this beaker and we're going to pour hydrogen peroxide on it. And we're going to take an ember. So I'm going to light the stick on fire, blow it out so there's just like that tiny little ember. And if we hold it over the reaction, it should light on fire again.
That's cool.
Right? Because what does fire need? It needs oxygen. So we'll get a big piece of liver for this. We can keep using liver too. I will say I have about an 80% success rate on this. So it usually works, but there's been a couple times where it's not worked as well as I would like. And I'm not really using a stick, so I'm also a little scared about burning myself, but that's okay. So,
Add the science Snapchat at. What's the science Snapchat?
oh yeah, in case the liver wasn't gross enough, you're gonna be reminded of this every time you go on Snapchat for the next 24 hours. Okay, so I just took a whole chicken liver here. We're gonna pour a lot of hydrogen peroxide. Thank you. I know I do shed a lot. Okay. Let's see. What happened? This might be the best stick. I broke this off a birthday candle. One of those like decorative ones. All right. Let's make sure this is gonna work first.
Yeah.
Okay. Getting it on camera too. Okay, we got fire. We have reaction. Ember. Come on. All right, when it does do it, it's going to be really cool, but it might take a second here. Come on. All right,
Maybe you
this
put
thing
too
went
much
out.
of that in.
Nah, it's just got to give it time to put enough oxygen. It's fine. Keep doing it until it works. All right, trying again. The key is to get that ember. Oops, and I just touched it. That doesn't work. Let's try the toothpick.
Come on,
All right.
Miss Gisborne,
I know. I told you, 80% success rate. These are also different tools than I usually have, so.
Whoa.
Ha-ha. Trying to find a nice oxygen spot without putting it out. No, put it out. All right, it worked though. It worked. We're gonna do it again.
Evidence.
Evidence. You guys saw, right? It went boop, and
Yep.
it lit back on fire. Pretty cool. People are going to be worried that we're actually burning something in here.
I know.
It smells really like fire-like in here.
Fire alarm.
Nah. I would actually have to light something on fire for that. Oh, oh.
Oh, do it. Come on.
Oh no, it's going to burn out before
Yeah.
there's enough
Burns
oxygen.
out. I made a little popping noise. I was like, didn't get it.
Oops. It's hard to not touch the bubbles. All right, sorry for people at home. You're probably like, can't see it as well, and you're just like, but it's cool in person, I promise.
Don't try this at home, kids.
You could do this experiment at home.
Adult supervision.
Yeah.
I'm sure your parents will be like concerned if you were like, buy me some chicken livers. Maybe it's burning out too fast.
It keeps burning out really fast.
There we go.
Yay! Right when it goes, I was about to push it. Okay, it's doing it again. Heel. I'm standing on one foot. It's like, oh.
You can see it like getting brighter.
Yeah.
But you saw evidence.
Okay, one more time, and then I promise we'll stop playing with the fire.
It's fun.
It is cool.
Yeah.
Plus, you're about to have to write about what we did. That's too short. Ooh, colored toothpicks. Will it make a difference?
Thanks.
Okay.
It's just so close.
It's so close. It's like not quite enough oxygen. What is that?
Oh, it's
There's bubbles on it. Okay. Notice though, the reaction is still just going. Producing tons of bubbles here. The liver is just happily reacting away. And then we're almost done with this, so. It's just the fire part's fun. It's fun. Not gonna lie.
Try a pencil.
Nice embers. Actually, I thought about using a pencil.
Do it.
Ooh!
oh, I hear the pop.
There's one right there.
It happened.
All right. So that's how we prove there's oxygen. Okay. So the rest of this lab is just answering these conclusion and analysis questions, right? Really try to use the vocab here. Talk about enzymes. Talk about what's happening. Hydrogen peroxide is being broken down into water and oxygen, right? Use the words and use the data. It's the biggest mistake people make when they talk about their conclusion is they just say, my hypothesis was supported. The data showed that. Okay, well, what was your data? What numbers did you get to prove your hypothesis? And then other than that, you're gonna be making a graph. You can do the graph on the computer. You can do it on paper, right? Perfectly fine. And then you're explaining how temperature affects enzyme reaction rate, right? That's really the part where you need to use vocab. In terms of reactions, it looks like our body temperature is still going, right? Just a tiny bit. There's like 1 bubble per second going here. So I would say body temperature was the longest. Other than that, this lab is done. This was a pretty quick one. If you didn't do the pre-lab questions, go back and try to do them. Just practicing reading about science and answering questions about it, and making sure you know these vocab words about enzymes, right? Activation energy, active site, enzyme substrate, complex, catalyst, denatured. Denatured being the most important one. And then other than that, if you have a question, let me know. Otherwise, I'm gonna end the meeting and you can email or text me if you have questions. The Snapchat is gonna be filled with videos of this. And otherwise, I don't see anyone typing in the chat, so I'm going to assume that we're all good to go. And we're going to end the meeting. Oh, wait, actually, let me write down who is here. Actually, just take a screenshot. My gross liver napkin. It's fine. Okay, we got Vanessa. Olivia, Mason, Keaton, Juliana, and Jessica. All right. Awesome. I got everyone written here. I'm going to add you in as attendance. When you're done, go ahead and email me your lab. Again, I'm just keeping track of this separately because Canvas won't let me add new assignments, which is just ridiculous. So I will be keeping track of this separately and adding points at the end of the semester. So when you're done with the lab, just go ahead and email it to me. All right. I will talk to you guys soon.